The derivative of the composition. This is the hardest rule. It's called the chain rule. And the reason why I think it's hard for students, because it's harder for students to understand what a composition is. All right, a composition means I put a function inside of another function. All right, so my function, my big function h of x, is really two little functions where I've composed them. I've taken the function f of x and inputted g of x inside it. So there are two functions, and what there is, there's an outside function and an inside function. So f would be my outside function, and g is the inside function. All right, and then we're composing them. We're taking g and putting it inside f of x. So some simple examples would be something like if you have, square root of x squared minus 4. All right, that was h of x. All right, so the outside function, there are two functions there. There's the square root, and then there's the quadratic. So there's the root function, and then there's the quadratic x squared minus 4. So the outside would be the square root. The inside would be the x squared minus 4. So those are the two functions that we're looking at. Actually, I would usually write this with some other notation like u. But that's what we're doing. We would take g and plug it inside f. Another example would be something like, which we'll eventually get to in chapter 2, but if I've got my natural log, the ln of 2x cubed, right? And so the outside function's the natural log, the inside function's the 2x cubed. All right, so there are two distinct functions here. There's the natural log function, and there's the cube function. All right, so we've got inside and outside that we can distinguish between inside and outside. All right, so that's important to understand when we get to the derivative of a composition, when I've got an inside and an outside function. All right, so the derivative of f of g of x. Right, this is the hardest case, right, just because it's hard to wrap your brain around. But there are two functions. And remember, when I take a derivative, I can only do a derivative of one function at a time. All right, one function at a time. All right, now this one is put together a little differently. And if you look at, make sure you do watch the book videos that kind of go to in a little more detail than I'm going to do. I'm just going to hit the rule and do examples. All right, so the rule is, all right, the chain rule is, I take the derivative of the outside function. So I take the derivative of f, but leave the inside function the same. So the easiest way to do it is f prime. So I'm taking the derivative of f, but I'm going to leave the inside the same. All right, so the only part I'm taking the derivative of what the part that represented the outside function. Then separately, so I did leave g of x alone when I took the derivative of f. Separately, and separated by a multiplication, I take the derivative of just g of x. So there is a multiplication, but I am only doing one derivative at a time. All right, so in words, what it is, we take the derivative of the outside function, using our rules, leave the inside the same, then multiply by only the derivative of the inside function. All right, so if I do like a simple example, so suppose I do the example that I gave up there. My function h of x was that square root of x squared minus 4, right? Which I rewrite the square root as x squared minus 4 to the 1/2 power. All right, the rule is I take the derivative of just the outside. So what I usually do is I hide the inside. So instead of hiding the inside, I'm going to let u be the inside. So I'm going to let u represent the inside x squared minus 4. That's what I'm going to let. And so u raised to the 1/2 power. Right. So the derivative of this is h prime of x is the derivative of the half rule. So it's 1/2 u raised to the negative 1/2, right? That's the derivative of the 1/2 function. But then I'm not done yet. The chain rule, because this u was an inside function, I've then got to take the derivative of the u expression, right? Which I haven't done yet. I just wrote it out here as the derivative. All right, so when I simplify this, I'll write it all out. So it's the 1/2, the inside, leave the inside alone. So the inside was x squared minus 4 raised to the negative 1/2. So that's the derivative of the outside, leave the inside, times the derivative of the inside, which the inside was x squared minus 4, so 2x. And there's the derivative of that function. Right, so if I kind of erase this middle part, where that's sort of my thought process. Right, so you look at here is the rule. This part is just the derivative of the outside. Alright, that's all I did was the derivative of the outside. We left the inside alone. Right? I took the derivative of the square root part. That's the 1/2 pulled out front, raised to the negative 1/2, left the inside alone. Then it was times only the inside derivative. Alright, and that's the rule, and that's the tricky part. Now, right now, the only rules we have are our quadratic functions and the power rule. Now, we will add to this later on when we get to exponentials and logarithms, and I'll talk about that when we get to those cases. But the chain rule, at the moment, really involves the outside function being a power function. Again, that will be all of our cases right now in Chapter 1 until we get to Chapter 2 with exponentials and logarithms. And so, for this part, Chapter 1, the chain rule is the outside is a power, the inside is a function. And so we've got, just like what that basically was this rule here, right? The outside function was the power 1/2, the inside function was x minus 4, x squared minus 4. And so the chain rule on a power function is, so I've got a function, so again, the outside is the power n, the inside is the g of x. The chain rule is I pull the power n out, times the group g of x, left alone. It's the same g of x that was in my original expression, but now that group is raised to 1 degree less. So if that was the half power, it's now raised to the negative half power. But then I'm not done. Can't stop there because I've only taken care of the outside function, haven't taken care of the inside. Then you have to remember times the derivative of the inside, and just the inside, all by itself. Alright, and so that's the rule that we'll be using in Chapter 1. That's the chain rule with the power function. We'll add to that later on with exponentials and logarithms. So again, just to do a simple example before I get to more examples in the next video. So again, a simple example would be, something like 10 times x to the 5th minus 3x plus 1 raised to the 4th degree. Right, now 10 is just a constant multiplier. It comes along. The 4th degree out here is the outside. That's the end part. And then the polynomial is the inside. That's g of x. So g of x is the 5x. X to the 5th minus 3x plus 1. And so when we take the derivative of that, well, 10 is just going to come along. It's a constant multiplier rule. We pull the 4 out front. So 10 times 4. And you could just write 40 times that group written as is. You don't change it. What changes is I get a new power. I get 1 degree less. Instead of raised to the 4th, it's raised to the 3rd. All right, but then I'm not done, and this is the part that's, if I'm going to forget something, it's the second part of this. I did all of that, but then you can't forget times the derivative of the inside. And so then it's times, and I just look at the inside function and take its derivative. And so the derivative of x to the 5th is 5x to the 4th minus 3. The derivative of 1 zeros out. And so there's that function, and basically the only thing I could do is I could simplify this. Instead of writing 10 times 4, that'd be 40. Right? And there is the chain rule. Right? And so we'll practice more examples and mix them together. The hard part is not just with the chain rule by itself, it's when we start mixing it with our product and our quotient rule where it gets a little trickier. Alright, so we'll do that in the next video.